hit that screen and then 2 down.
Okay.
Ready? All right, here we go. I want to talk to you tonight about ground fault circuit interrupters. There was a farm worker who was using an Atlan pressure washer, a high pressure washer. And he used it to wash out pig pens, pig farrowing pens. And the 240 volt 30 amp pressure washer had a GFCI cord on it originally. And they decided to replace that cord with a non-GFI cord. And they found this farm worker, the employee, lying in a hog pen. And they administered CPR to him, and it didn't do any good. And it was found that the guy was electrocuted by an apparent ground fault. That's a actual OSHA inspection report from January 1999, where this farm worker lost his life because they had modified this machine and taken off the ground fault circuit interrupter. This tragic report ends with a man losing his life. And the really sad part about that, it was totally preventable. I'm a master electrician for 30 years. I've been in the trade. My experience ranges from residential, commercial, industrial, and the aerospace industry. I've seen I know cost-cutting measures. I know how to get the job done cheaply. And I've dealt with the headaches after the contract was completing of a job that went to the lowest bidder. I've dealt with individuals who get tunnel vision, and they'll use defective equipment just to get their job or their test completed. And oftentimes, a piece of equipment will cry out saying there's something wrong with me, especially when a ground fault circuit interrupter is used. I don't really know what the exact events were that day when that guy lost his life, but from the report I can surmise a few things. And I'd like to talk to you a few minutes about those failures that happened in that report. And I'd like to give you a brief explanation about a GFCI and how it works and the importance of testing a GFCI. The pressure washer was purchased to do the glamorous job of washing out hog pens. The hogs were part of the hog pens were owned by one of the largest hog producers in the United States. So the question of maintenance cost shouldn't have been an issue because they were a big enough company they could afford to do proper maintenance. And judging by the size of the fine that OSHA fined them for that, it wasn't an issue because they only charged them $3,500 for the infractions that they found. And if that had been a serious issue with the company, it would have been much more than that. The pressure washer saw its days of abuse. The days led into months, and the months into years of using this pressure washer to wash out hog pens. It was thought by the workers. They said the pressure washer worked great yesterday, so there's no reason for it not to work great today. But the problem was that yesterday, the cord got tangled up with itself, and the worker was on his last row and nearly to the end of the day. And he didn't have any thought about giving that hose one little jerk so he could get the slack that he needed to finish up the day. And as he was picking up his equipment that day, he noticed that the electric cord had pulled out of the machine and the wires were exposed. And he said that, you know what, he looked at the wires, they weren't damaged, so he just stuck them back in the hole and snapped the cord connector in place. Well, the next day a worker came and he flipped the switch on and turned the water on, and the reset button popped out. And he looked at that reset button and he remembered he had one of those aggravating reset buttons at home in his bathroom. Every time it rained, it would pop out, even when nothing was plugged into it. So he was thinking about that. He started pushing that reset button on that GFCI. He kept pushing it, and he kept pushing it, and he'd wiggle the cord, and he'd push it, wiggle the cord, and finally that reset button stayed in. And he finished the day out and got all his pins cleaned out. Well, a few days later, that aggravating reset button wouldn't stay in for anything. He'd push it and it just popped right out. So it was decided the aggravating reset button was bad. And they was going to go get a cord out of the maintenance shed and replace that cord with a new cord. Well, this new cord was like the old one, except it was bigger. So if it was bigger, it had to be better. And the best thing about the new cord, it didn't have an aggravating reset button on it. So they put this new cord on there, and they went to put the connector on there, and it wouldn't fit. The new cord was bigger, so they just threw it away. Well, a few days went by, and they didn't notice water seeping in around that new cord, getting into the machine. And finally, the last day or the next day, the worker come in, and he's thinking about a great day of washing out hog pens. And he was thinking to himself, he said, you know what, I should get rid of that aggravating reset button I have at home, because I don't need it anyway. This machine worked fine without it. And as he was thinking that, he flipped the switch on for the last time. As an electrician, life is good when electricity stays in the closed loop we provide for it. But life is seldom easy and convenient. Sometimes we have shorts or ground faults in a circuit, and when large amounts of current flow through a ground fault, it'll trip a circuit breaker right away. It's noisy, it's scary, and it's dangerous when that happens. But the good thing about that is it trips within fractions of a second. But the real killers with ground fault are the small leaks, the ones that do not leak enough current to trip a normal circuit breaker. Those are the real killers, because the current leaves and it just goes undetected. And we use ground fault circuit interrupters, or GFCIs is another name that they're called. And they detect those small leaks. And they'll trip when they detect that leak. That's a GFCI. All GFCIs have on them a test button and a reset button. And the only way to know if a GFCI is working is if you push that test button and test it. Because a lot of the manufacturers make some that'll just keep right on giving electricity and then not working internally. So the only way you can know if that's working is if you push that test button and it pops. And you hit the reset button and it goes again. And from that, there are three basic kinds of GFCIs. There's a GFCI breaker. I got a picture of some of those. There's a GFCI receptacle. And a lot of you probably have those in your bathroom. And then there's a GFCI extension cord that has it right on the end of the cord. And there are other types, but those are the three most common types. We need to test the GFCI every time we use it for two reasons. The first reason we test the GFCI is to make sure it works. It's the obvious reason. We push the test button and it pops out and it works. We hit the reset and we keep going. The other reason to test them is to build our confidence in the device itself. When you push the test button on a GFCI and you reset it, you go on about your business, that builds confidence in you that this thing is working. And you have a reference point when things change and you push that reset button or that test button, and it doesn't pop out, you know the unit's gone bad. Or you're using it and it just pops out for no reason, you know whatever's plugged into it is gone bad. So that's the importance of testing it. Now if you'll go ahead and show the slide, I'll show you a couple examples of GFI. That's a square D circuit breaker panel. If you push that yellow button, it'll trip the breaker, and you know it's working. All right. The next one he's going to show is just a different brand. And instead of having a yellow button, it has a white button. That's Siemens brand. It just has a white button instead of yellow. Same thing. You push that white button and it trips. And then you reset it and go about your business. I show one of the clips. That's a GFI receptacle. Notice that green light on there. That receptacle's on. When you push that test button, the light goes off. Then you reset it and it comes back on. You know everything's good. All right, go to the next one. All right, that's a GFI receptacle. You just push that yellow button. The handle trips. You turn it to the off position. Then back on and you're good to go. That's the simple test process of testing a GFCI. It only takes a couple minutes. And my wife brought up a good thought about that. He said, when you push that button, it is an actual test. When you push that button on the unit, it sends out a calibrated current to the protective circuit inside there. And that protective circuit senses that current and trips. So it's not like just turning it on and off, yeah, that's good. When you test the button, it really does a test. And probably the biggest thing I hear about an objection to those things, one, they just trip for no reason, and the other is that they are expensive. But the real question is not how much it costs, but how much you value your life. That's the real question. So I implore you, I beg you, when you get home, go in your bathroom and push that test button. Then hit the reset button. If nothing happens, it needs to be replaced. If something does happen, you reset it and everything works, you know it's working. That's the conclusion of my speech. And you go ahead and shut that off. Anybody have any